Thank you so much, ladies and gentlemen, for joining to today's session. Welcome to UNISA Science Engagement Center live online learning session. Please follow us on our social media pages. On Facebook, we are ISET Lego. On YouTube, we are ISET UNISA. And if you also need some further information regarding joining the MOOC portal, we are mooc.unisa.ac.za/portal. It's a happy Monday, and without wasting time, I'll hand over to Mener Johannes for the house rules. Thank you so much.
Thank you so much, Tamela. Welcome everybody to today's session. It's the second unit of M1. We only have a few small house rules for today. We would like to ask everybody to please mute your cameras to save data and bandwidth. Also to mute your microphones to keep all the background noise to minimum. If you have a question at any point in time, please feel free to raise your hand. Or if you have some mic problems, please enter it into the chat area. There will be question and answer sessions between the presentations. And then that's from my side. Over to you, Dr. Gous.
Thank you. We're just trying to synchronize everybody here. All right. So indeed, this is Unit 2. You have the whole of tomorrow to ponder what Unit 1 and Unit 2 was all about. So basically, by the end of this session, you'll be able to build and program a robot to at least move forward and move backwards. And so that's the exciting part of it. And I'm really encouraging you to download the software and play around. I'm going to Sylvia said she'll give you a demonstration, and now I've been locked out of my laptop, so that's not helping. But she has volunteered. She'll be back on Wednesday online, and she'll give you a tour of the Spike Prime kind of programming canvas, and so you can see how to program the robots. All right. So really, when we do workshops as well, we kind of tell the learners we are going to make the robot move. So we're not doing programming. You really need to create the excitement and overcome the fear of programming, because it's just for too many, it's this perception that programming is oh so difficult, which it is not at all. And it actually can be a lot of fun if you get the robots to move properly. And if their robots are well behaved, it's even more fun. Okay, so I'm going to I've only got 2 short presentations, and then we will kind of try and demonstrate also how to program robots, and then we'll move forward on that. So maybe just before I go into the presentation mode, if you have a robot with 2 wheels, if you imagine yourself driving a robot with 2 wheels, is there a robot here? No, that's all the robots are. And so your output is the motors that are turning, and so as your motors turn, your wheels turn, and so that makes the robot go forward. And the opposite of going forward, which is positive, is then negative. It's then reversing. So there you've got already navigation forwards and backwards. And that's as easy as that. And so once you've got the robot to go forwards and backwards, then you've already got movement, which is really cool. What you also want to do is, how does the robot turn? Well, the robot turns if you've got 2 motors and you switch the one off and you let this one rotate, then naturally the robot's going to move in that direction. Or if you turn this one off and you make this motor turn, then your robot will then turn in the other direction. Again, if the learners get it, then it's all that much easier to learn to program, because they've got they're understanding what they're doing. And so I would encourage you to do lots of navigation, lots of moving forward, touching things, coming backwards, going forward, going around something, coming back, going around a bucket, going around a square box, going around. And you'll see in Unit 4, we do passive attachments. And then it becomes even more exciting, because then you go and fetch things and drop things. But you want the robot to move. And so that is, yeah, it's a fun introduction, but you've got to get the robot to actually move. Okay. All right, so let's start with the session, and I'm going to share my screen as always. There we go. And then of course somebody's going to say yes, they can see my presentation or something like that, and they're going to monitor there we go. All right, and then I was told I've got to hide this thing as well. Okay, so we are going to now start the basics in terms of programming. And the programming part is where the robot is moving. You're going to build a robot, build with building instructions. You don't have to design your robot yet. You just need to build it. And now we're going to make it move. And so you know about the navigation information. You know all the people on the team here, really keen and eager to help you. All right. And now we're going on to programming. And by programming your robot, there's output. And the output then makes sure that the robot will then actually move and not just stand there and do nothing. All right. So yeah, this is an amazing race, and we're all survivors. But you're on session 2 of 4, and I think we just keep going. Just keep going with what you've got. All right. Okay, so again, it's about equipping our robotics coaches, and the focus is to have competent and confident learners. You need competent and confident robotics coaches. And so ask the questions. I noticed there weren't many questions in the previous session, but as you're going through the work and you want to ask the questions and maybe we're not in the session anymore, please send us an email and then we'll answer it the best we can. All right. So again, we're always moving from the basics to beyond, and we're going somewhere, but we have to actually start somewhere. And so today we've started with the engineering and the programming, and then tomorrow, no, not tomorrow, tomorrow's a holiday. On Wednesday, we'll do some 21st century skills and how that applies in robotics. Okay, and not only applies. So this is a little bit of the kind of evolution of a robot. And if you look over here, this is where it all started. These robotics kits only started with an RCX kit. And then it was very quickly upgraded. Where's my upgrade to the NXTs? And the NXTs we kind of started 2006, and for a long time the NXT was fine. It was fine, but you know, our learners then take the challenge with both hands. And so we upgraded into to EV3s, allowing for bigger programs. And now the new kit on the block is then the Spike Prime. Yeah, it looks like back to the yellow, back to the small, but it's a good place to start. And you need to look in the future. What are we developing? We're developing 21st century skills. We're developing skills that learners can thrive in the 4th industrial revolution and beyond that as well. It's not just for the now, and it's not just survival mode. We're now thriving. We need to equip our learners to thrive. All right. So our Spike Prime robotics kit will kind of look like this. This is one of the designs, one of the drive bases that we have. So in terms of programming languages, if we have an EV3 kit with the gray kit, we can either, this is the EV3 lab programming version, nothing wrong with it. This is just where it was, and obviously moving on. So they've now changed the programming language to go more in line with Scratch. And so this is the EV3 classroom programming, where we're going to have a live demonstration by Sylvia, hopefully on Wednesday, if I can get my laptop unlocked, whatever it is. But maybe a time for you to then go and dig and discover and see what you can find out about the programming language. Very similar, or looks exactly the same as the Spike priming programming language. And if you've been doing if you've been doing Scratch with your kids in class, it looks the same. All right. So this is the introduction to the programming language. Let me just stop this one, and I'll put the other one up, and then we can go through that. And then I'm going to again ask, can you see my screen? Okay, all right. So with programming, and I'll just, when we do programming and I teach Python in 1st and 2nd year, it's a text-based programming language, all right? So it's important about indenting, and it's important about syntax, and it's important about semicolons and colons and dots and you name it and whatever. So at the very core of programming, it's abstract. And the abstractness is just actually worsened by the fact that the programming language is rather abstract. So on the continuum of programming languages, towards the left-hand side, you go towards icon-based programming, which is drag and drop. And what you drag and drop is exactly what you see. And so that removes then the abstractness of it. If you use your programming then to make a robot move, then that's definitely concrete. All right. So in this example, it would say the 2 motors going forward with 50% power, 1 rotation, and it's motor B and motor C. Okay, that is exactly what it's going to do. So if you run this, the motors are going to turn with 50% power, 1 rotation, and then it's going to stop. And then it's going to wait for 1 second, and then. So there's nothing abstract, but this is definitely a good way to introduce programming on a very concrete way and perspective. Okay. Okay, as always, in the overview document under syllabus, there are some questions or some things to ponder in Unit 2, and especially about programming. So you should be able to say, what are some of the problems if the robot doesn't function correctly? Well, first of all, it won't function if it's not switched on. And secondly, it's not going to do anything unless it's programmed. Okay, and so that is one of the first things. You actually have to program the robot to do something. The robot is very obedient. It'll only do exactly what it's told to do. So you as the coach, and I'll do some debugging, you as the coach need to be able to look at programming or program and say, ha, that's where the issue is. I must say we had a lot of fun in the Free State with teams programming the robot and then making really very small slip-ups, and then the robot would either go too far or not far enough, or just suddenly stop. And so as you as a coach need to be able to see immediately where the issues are. All right. The directions with the wheeled robots, can it move forward, backwards? It can go forward, left, go forward, right, can go reverse, left, reverse, right, and it can also do a wheelie if you put the wheels in the opposite direction. But the learners need to be able to explain how a wheeled robot actually moves. Okay, and it's about output, it's about motors, it's about gearing, it's about the circumference of the wheel. Oh my goodness, circumference is a maths concept, yes, but it's applied in robotics. So the bigger the wheel, the bigger the circumference, the longer or the longer the distance that the robot will travel in 1 rotation. Okay. Also, how do you program a robot to turn left and turn right? And then why does a robot that is programmed to move forward for a specified number of rotations go further with bigger wheels than with smaller wheels? Tell me why. And the learners need to be able to explain this with confidence. All right. So again, each of the objectives, you need to be able to move the robot forward. And there's 3 options: rotation, degrees, and seconds. And it's a good example to say, go forward 3 rotations, go forward 3 degrees, and go forward 3 seconds. And then you mark it with maybe a piece of chalk on the ground or on the floor that you're working on, and explain why is the one further or not so far than the other. The other one is putting a weight between changing direction. So you go forward, then you have to wait 1 second, and then you've got to move backwards. And so that is, again, to avoid momentum. And so all these little detail, there's always the detail that the learners need to kind of include. And number 5 is you to put a sound in to make sure that when when the truck moves back, it goes beep, 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 beep. So put a sound in, and you know exactly where your robot is moving. Okay. So this is an example of how to make the robot move forward. So in the EV3 lab version, I would reset both motors, and I'd reset them because there's accumulation on the slippage on the gears inside. And then I would say move forward with 50% power, say 3 rotations. All right. That is exactly the same as here. And for this, we had ports C and D connected to the motors to turn the wheels. So it says set the speed to 50% power and 50% power, and then you move forward for 3 rotations, and then you stop moving. Exactly the same thing. Here we've kind of combined everything and said set movement, motors to C and D, and you move for 3 rotations at 50 and 50% speed, and then you stop moving. Exactly, again, the same thing. All right. So the EV3 software, again, it's a canvas, but you'll also notice, and in SpyProm, I need to actually get that screen as well. There are a whole lot of teacher aids and educational things that you can use, tutoring that you do not need to really create much other than follow the resources that are already available included. All right. Again, you'll start a project. We're going to start a program, and then on the EV3, you just drag and drop. So you drag this up, you drag this up, whatever icons you want to use, you can drag them and put them there. And then when you're finished putting your program here in line, you go to that button over there, and then you download it. Okay. onto your brain, onto your robot's brain. I'll show you just now when I demonstrate. If you double click on program, you give your program at least a name so you can identify it easily. And Sylvia will explain later that when you do when you do spike primes, the naming of your program has kind of fallen by the wayside, which is quite sad. But it means that you have to have kind of a sideline list to know that program 1 is this and it does that and where it must start and how it must move. And so it gives another learner a role within the team to kind of be the, I don't know, the program caller or the program crier or something like that. Okay. So this is just a convention. And obviously you in your class are going to have some conventions to make your life as the coach a little easier, that you can detect errors and omissions much quicker. So for this robot, if you were to stand kind of behind the robot, remember you always got traction that goes, the wheels that must go forward. So that must hold onto the road. So if you stand here behind the robot and you're looking forward this way, and this is forward, then your left-hand side must be B and your right-hand side must be connected to port C. And that just gives me, I mean, if you have 30 learners in your class and you're doing robotics and one robot's not behaving, you need to be able to very quickly see where the errors could be. And so this is one of those conventions. Just makes it slightly easier, and the spike is a little different. Obviously, it's a little different. Everything has to be a little bit different, but we'll get there. Okay. Okay. So again, for an EV3 robot, if B and C must rotate forward, is positive, and then negative must be backwards. So it's the application of physics, pure physics. Okay. And so an example here, there I said you just put a weight in. So you go forward, you wait, and then you turn. So you've only got one motor turning. So you'll turn to the right then. Okay. And again, here you've got B and C, you've got going forward, and then you wait for 1 second. And now you've introduced A, but A is connected to a media motor, which means that it is a third motor that you've connected to port number A. And we use the media motors for power, so for lifting and dropping things. And that could also be just another thing that we do for power detachments. Okay. So good programming, it's just good habits that you need to start the learners as early as possible and just to include it in your teaching. So the one is resetting the motors. So B and C, you just reset them. It's like ready, steady, go. Reset the motors, and you can reset them as often as you like. The other one is adding weights, having pauses. You can also, when you start with robotics and with the learners, make that 2 or 3 or maybe 4 seconds. So you definitely know where your robot is going and where you need to modify your program. And then as you refine your programming, say before you go to a competition, you will then reduce that from say from 5 seconds to 1 second, because you obviously you don't want to wait too long. You don't want to waste too much time. Okay. Oh my word, save the programs. So I highly suggest that when you save your programs at the end of the class, if you can invest in a one of these wearable USBs or something like that, or if you have a spare hard drive, and to get the learners in the habit of saving their programs, okay, and as often as possible. There should be a naming convention which I propose, and I can show you how it works. But basically, if you have your project, if you name it with the date in it, so you would say 2022, and today's date is what did we did? 08. There we go. Okay, and so you save your program, and then tomorrow you take another copy of your program, you save it as 0809, and then you work on it so that you know that yesterday's program is still safe and intact. Yeah, I will. You really need to make sure that you keep versions of your program, because it's not fun to come at the end of, especially when the learners are working so hard and they've got a beautiful program, and then somebody will come and say, "Oh, ma'am, I just deleted it." No, okay. Yeah, or the laptop just drops, or the laptop, no, that's also not a good example, or the laptop gets dropped in water or something like that. But whatever way you do it, you've got to have backups. Test your code regularly. Please do not just write pages and pages of code and then put your robot down and hope to goodness it works. It's not going to work. All right. So you do little pieces of code. So if you've got to go forward, turn, and then go straight, then you do the forward first. Then you do forward and straight and turn, and then you do forward and turn and go straight. And so you add little bits of code that can be reused. And you'll see here I've added comments, especially if you have 2 or 3 learners all working on exactly the same piece of code. Yeah, comments. And even if it's sticky notes all over your laptop, that's also fine. But you do need to keep kind of tabs on what's going on. Lots of comments, more comments, and lots of comments, and definitely comments. And so even if you have, what I do find is that learners need to write up what they did today, maybe in the beginning what they intend to do, and then kind of on the second half of the page, what did they actually accomplish? And so it gets them realistic. You're not going to get a brand new robot scoring 500 points on a robotics challenge. It's not. But if you say, let's aim for say 100. Let's aim to get 100 points. How best can we get to 100 points? And then if you get to 100 points, then you challenge the team and you say, are we going to try 120 or are we happy with 100? And then let the learners decide. Let them take ownership of that. All right. Okay. So just on move steering and move tank. Move steering is when both large motors are moving at the same power. And it kind of keeps the robot going straight. If the robot is not going straight, there are a lot of videos when you can Google, what if my robot's not going straight? And I've got a couple. I think the team Veneer had a really cool video where you can test it. So then you really need to have exactly the same. So you see here in B and C with move steering, they both have 50% power. So the robot is definitely going to go straight. If you do move tank, you usually have different power settings. So you'd have for one rotation that 30% on the one side and 40. So your robot is trying to really go over tough terrain. It's like these big army tanks. It's going over tough terrain, and that's one of the ways of doing it. Or if you want to make the robot turn, then you would use move tank. Okay. So recognizing the motor and sensors in the software. Again, remember I said to you last time, we've got over here, we've got the motors, that's the output, and over here we've got the sensors, that's the input. The wires actually need to click in. So then when you program at the bottom right-hand side, it'll say port A has got a medium motor, port B has got a large motor, and port C has got a large motor. And then port 1 has got a touch sensor, port 3 has got a light sensor, and we'll get to this next week, and that's reflective. And port 4 has got an ultrasonic sensor, and the object it's seeing is 32.6 centimeters away. So you can already see what is connected and what is not connected. All right. What I do want to say is that sometimes you think the robot knows what it's doing, but it doesn't. All right. So if you program B and C to go forward, and then it doesn't turn or doesn't go straight, then maybe you've connected the wires in the wrong ports, or maybe you do need to make sure the robot's not going to tell you, I can't see something or I can't touch something. You actually have to make sure before you program that what you're programming is what's actually going to happen. All right. And so we're going to do a demonstration, but not today. We're going to do a demonstration on Wednesday. I'm going to give you some time to go and play around with the programming. But what I do want to say is that when you program, there are a whole lot of resources that you can use. And if you have a Spike Prime robot, use the Prime lessons and work through them one by one. This is Builder Dude 35. This is Kyle. He's got a whole lot of tutorials. And maybe if you've got nothing to do tomorrow, maybe just go through some of the resources that are available about programming. Okay. Some of these links are very long and some of them are not so long, but some of them are helpful and some of them are not helpful. It depends where you are. And if you just want to sit and watch, something will click and something will be meaningful to you. We all learn differently, but here is a good collection of how-tos. Okay, and then we are back to Tamelo's MOOC, and he's already said that he's quite happy to answer your questions. It's Women's Day tomorrow, and Tamelo, you are not taking a Women's Day? I'm asking. Yes. Yeah.
No comment.
All right. So we've got an echo here. There we go. All right. So you've got some homework for tomorrow. Now you've got Unit 1 and Unit 2. But I really would encourage you to write some programs and ready to try and do all the programming activities in Unit 2 that we explain. How to go forward, how to go back, how to turn, how to go reverse. And then to get the code and download it. And there's obviously lots to do with programming, but navigation is priority number 1. We'll do some problem solving tomorrow. No, not tomorrow, Wednesday. We'll do some problem solving. We'll go through some steps of how to link the problem with the programming solution. We'll do all that as well on Wednesday. But really what we're doing with programming is we're just making the robot actually move. That is the focus of it. And so going forwards, going back, turning left, turning right, reversing, there's lots you can do, lots to learn, stopping, going, using 50% power, using 100% power, using 0% power, and then you wonder why the robot doesn't move. It's because the power is 0%. All right. Okay. Oh, yes. And so Sylvia's just saying here, you can also, there's many ways. Maybe don't tell the learners exactly how to do the problem. Maybe just see how they figure it out and see how all the different ways of actually programming a robot to do maybe a simple task of just going around a square or going around a block, or make it exciting, go around a chocolate. And if you get around the chocolate, you can have the chocolate. You see, there's many ways to make this really exciting. All right. I'm going to stop sharing and I'm going to, are there any questions? Are there any questions that on programming? So programming is about persistent practice. And I would encourage you just to sit and play with programming, try some examples. We'll start with a Spike Prime session on Wednesday, and I'm also there. I will see whether I can figure out something. Yeah, we're in this transition stage now. So some of the materials we've updated already. We've got a long way to go still, but we'll get there. There's a lot of debate on how to move from the one to the other. My gut feeling says let's all move to Scratch. So if we have an EV3, we use EV3 Classroom. If we have a Spike, we obviously use the Spike. So just on that note, there is a really cool free resource. It's called I think it's called Gearsbot, like that. Yes. And that's all online. And so if you don't have a kit, the robot doesn't look really cool, but it's like little. But you can build a little robot and you can put a couple of attachments onto it. The programming. Okay, so every learner, if you've got a computer lab, install Gearsbot on every computer, and then every learner has their own robot that they can then manipulate with programming. The cool thing about Gearsbot, apart from the fact that it's new and we're testing it, is that you can program it in the Scratch programming, but it also gives you the Python equivalent. Remember, we're trying to encourage our learners to kind of move up. We want them to become competent and confident programmers. And so the only way you do that is you build the confidence to say, okay, program now in Scratch and then see what the Python equivalent is. Yeah. So just maybe on that note as well, in September, we're going to run some Python workshops as well, introduction to Python, and you're welcome to join those as well. But especially for the little ones, we really want them to engage with programming in a fun way. On the other end of the scale, there's also Scratch and Scratch Junior, and so that the learners can actually do some programming. And yeah. All right. Are there any questions? Are there any questions? Nobody's raised. Yes.
I can share my screen if you want to show them how the program looks, if you maybe want to.
Okay, you can, yes.
Casper, just which one are you showing? EV3 Classroom, okay.
Either Classroom or Spike if you want to.
Well, no, EV3 Classroom is fine for now. We'll cover Spike on Wednesday, but I'll probably open both and compare them a little bit.
Okay.
Yeah. Okay, so completely different interface. You've got your home, you've got unit plans, core set models. Both the Spike and the EV3 Classroom come with building instructions and units that you can, just like Patricia said, you just follow the units, quite easy. You can let the kids do it by themselves. There's a little guided programming bit in it. So if you click on build, I think it's empty at the moment. I'm not sure why. In EV3 Classroom, in Spike, there are designs there. That's where the little robot. Oh, okay, no,
Oh,
okay.
there we go.
For some reason,
cute.
okay, sorry, mine is blank. Okay, yeah. So you can see there's a couple of robots in there. That's usually the little book that comes with the EV3. The Spike doesn't have a book, but all its designs are just in the program. Then you've got your units. Okay, yeah, you can see that there's a lot of interesting stuff. There's also a little kit that you can buy from somewhere. That's a space kit.
Oh, that's a space kit. Oh,
Yeah,
that's the Lego
that's it.
space kit. Yeah.
So Casper, if you just go to units, please. Units next to build.
Okay, go back to units. Here we
It's
go.
like remote control with a voice.
Casper is my robot.
There we
Yeah.
go.
I can give Tamela control.
No, it's okay. So yeah, there's little unit plans there. The robot trainer is what Patricia was talking about. I'm just teaching you how to drive, basically. Again, it's one thing she didn't mention with the programming is we say Python and we say all these complicated things. Please bear in mind the stuff is not as intimidating as it sounds. It's made for 9-year-old kids. You will pick up on it a lot faster than you think, and then at one point the kids will pick up on it, and they will be explaining to you how everything works. So you really don't have to try and be absolutely on top of everything, but it's good to at least have some understanding so that the kids don't come bombard you with all their knowledge and information. Yeah. Okay, and then if you just go to start is also just another unit. If you go to home and then just start a new project, please, Casper. Yeah, so you can see that says recent projects, new projects. Okay, so again, you're working with a canvas and a block palette. All your blocks are there on your right-hand side. It's just a very long list, so it's just scroll past. It's also just drag and drop, same as the other program. You just drag a block onto the canvas, and they're shaped like puzzle pieces. So if they fit together, they fit together. Oop. Somebody trying to ask a question? Or did they get unmuted? Or
No, we're good.
okay.
Okay.
I'll give you a chance to ask questions this one. Okay, but yes, it's just basic drag and drop style. I would consider this a little bit easier than the EV3 lab just because the blocks are written in English, so the kids can read what they do instead of having to interpret it. But yeah, and also for kids that have done Scratch, you'll see they will just
thrive.
Yeah, they will just take over completely because this interface is familiar to them. Up at the top, above the block palette, you can see the project name. In this case, it's Project 2. Again, the Spike uses a completely different set of things, but I will show you that on Wednesday when we actually have a robot. So yeah, there you'll name your project. Unlike EV3 Lab, these programs are all separate. So you make each program on its own. So when you back them up, you have to go into My Documents, find the file, and manually select the ones you worked on, and then put it in a folder with the date. But I will again show you that on Wednesday.
You'll give us examples.
I will give you examples with images because nobody's going to remember this. And then up at the top, you've got your little connect button. It's the same. A lot of this is exactly the same as the Spike program. Again, we'll cover it. That's where if you plug your robot in or if you've got your Bluetooth on, it'll show you there. That's also where you get all your sensor readings. So if you would like to measure how far the arm has to go down, you reset your motors to 0. You plug your robot in and then you move your arm manually with your hand. You move the motor. And then you'll see the little counter for that motor is going to go up and up, and it'll show you like 300 degrees. And then you know, okay, it takes 300 degrees for the arm to go from its resting position down to the bottom. Yeah, and the block headings are still under the same
shade.
Yeah, they're all different shades. They all have different purposes. I couldn't explain it to you now because this is how it's separated in most programming languages. Operations, events, variables. Okay, they wouldn't have motors and things like that. But all of this is just little chunks. At the bottom, you've got your zoom, unzoom, your undo, redo buttons, and then right in the bottom right-hand corner, there are 2 buttons there. It is different in Spike, but again, we'll cover that. There's the download button, which we normally use, and then there is download and run, which is if you have your robot connected to Bluetooth and your robot is safely on a table with borders, then you can use download and run because that downloads and immediately runs the program.
Otherwise, it's chaos.
Otherwise, it's chaos. But I think we need to have a robot safety class at some point where we teach you how to pick up your robot with 2 hands and stop the robot and then pick it up, or pick it up and stop it immediately, but don't grab the moving motors and don't drive it off of tables that don't have edges. And if you're practicing somewhere where you don't have a mat or a surface or whatever, then you practice on the floor because the robot can't go any further than that. Yeah. So that's just a little basic overview of it. Unfortunately, for a lot of people, EV3 Classroom and the Spike app are only available on Windows 10 and only certain versions of Windows 10. But the system requirements are on Lego's website. So if you think you want to download it, just check the system requirements. It's got like a little version number there, and it even tells you how to check it. And then you can go do that. Otherwise, if you don't have it, the Spike app does have an online version. So if you at least just want to look at the stuff for now, if you go to Lego Education's website, go to the download button, the first thing it'll ask you is actually launch web app. And then you can actually program as much as you want in there and play around with it. You just can't actually connect a robot and download anything. But at least then you can go look at the blocks. You can click on all the buttons you wanted to see what they all do. Put things together, see if they fit, see if they don't fit. And also, again, because it's a Scratch programming language, there's a lot of support and a lot of resources that explain this programming to you. That's also where EV3 lessons and Prime lessons come in. They also have very detailed, I say very detailed, it's very concise but detailed descriptions of how to do everything. So they start with motors and movement, and they explain if you want to turn, you can use the tank move, or you use one wheel. And they also tell you like in what situation that would be better. They've also got little challenges and things that you can let the kids do, and then they've got the memo there as well. It's, I don't know, I use that to teach myself the Spike programming, so that's quite nice.
And if they really get stuck, you can send Sylvia an email.
Yeah, if you've got any technical issues with either the robot itself or with the program or with the programming logic, I can also just help you into figuring out whether what you want to do is possible, because I've played with the robot enough to know how to program it to do what you want it to do, or to just fix the logic. Okay, and Casper is showing you now, you can download it either from the Microsoft Store or from Lego Education's website in a normal browser.
And what's nice about when you do it in the store, it says for you, to you, this product will work on the. Yes.
Okay.
Yes, you can check that and then download it from there.
So installation without the frustration.
Yes.
Yes.
Perfect.
There's maybe one thing I want to maybe say, maybe want to add.
Yeah.
Using the classroom and the new Spike, there is something we have to do in the ending. We have to put a stop, an exit program, or else it will go infinitely the program.
You're just entirely gone.
Yes, the only thing I wanted to say was the stop function here. Yeah. Dr. Host, you are muted.
Okay, I think somewhere along the line we lost each other, but it's okay. We're here.
Oh, wait. Casper, I know what you're talking about. Oh, sorry. With the EV3 lab, you don't need to explicitly end your program with a block, but with both the Spike Prime and EV3 Classroom, you basically make a little burger. So you've got the top of your burger bun, which is one of the round blocks, the event blocks.
Yeah.
And then the control block that says stop and exit program actually stops your robot from running.
There we go.
Yes, there we go.
And it's level.
And it's level at the bottom. So again, they fit like puzzle pieces. If it's level at the bottom, you can't add anything after that because again, it's stop and exit the program.
Straight.
So if you're busy programming in that, you must always have the burger look. I would say with all your stacks, but depending on which option you pick there, you can end one stack of programming, but that's a lot more complicated. So just remember there's a burger. The little round cappy at the top and then the one at the bottom.
Where you can't
Otherwise, everything that you just drop in the canvas that's not connected to that top little burger bun is not going to run. So you can leave programming blocks there if you're busy testing things. It doesn't always look the neatest, but obviously while you're still busy, can you just drop a block randomly on the canvas?
Okay.
Just anywhere that's not connected.
There we
Yes.
go.
Okay, so in this case, if you run the robot, it'll only run the 2 blocks that are in the burger bun, and that top one won't move, and neither will the other one.
It's just standing there.
It's just standing there. So if you're busy testing a lot of things at the same time, you can drop blocks there. And to delete blocks, you just drop them back in the palette. You just throw them back into the palette. They'll disappear.
Awesome.
But yeah, we'll cover it again on Wednesday. And if you have any questions,
I said at UNISA, and then we'll redirect it to Sylvia.
We'll get redirected.
Yes.
Or if you go look at the programs now and you have any questions, write them down and ask again on Wednesday when I cover EB3, when I cover the Spike app as well.
Yes. Awesome. Are there any questions? You can see this is all about teamwork here. Thank you, Casper, for being remotely controlled.
Yes, thank you for that. Helps a lot. Oh, also, if you work in the Explore category, the Spike Essential also uses the same app as the Spike Prime.
Yeah.
Which is why it's very essential that you know which robot you are using, because if you click on Spike Essential, you get a whole bunch of different options, and then you will be lost.
Yeah. Terribly lost.
Not that you can't change to the other one, but you'll just be a little bit confused, and you need to know how to switch back to the other one.
Now, Spike Essentials for grades 1, 2, and 3.
Yes.
And Spike Prime is from grade 4 upwards. All right. Okay. Thank you very much, Casper, for sharing your screen and allowing us to control you. All right. Any other questions? Any other questions that anybody has about programming the robot, making it move properly? Okay, so we'll start Wednesday with some more practical stuff. We'll actually show you how to make a robot actually move. And and if there are any other questions that you think up in the meantime, please share them with us. All right. I'm just going to check the chat. Are there any? There's no more. All right. There's no more comments. There's no more questions. Anybody last chance? Last chance for some comments. Okay. Let's just have a look who else is here. All right. Okay. Awesome. So thank you, everybody. Thank you really very much for joining. Tumelo, do you want to close the session for us today?
Thank you so much, gentlemen and ladies. It has been a pleasure hosting you. For those that have been watching this recording, thank you so much for taking the time to watch the recording. And for our live participants, thank you so much for joining us all over the country. I even see you even have Dorothy Mlambo from KZN. And please don't hesitate to email us on i-set@unisa.ac.za. Please follow us also on our Facebook and YouTube social media pages. And I would like to leave you here, and I'll see you on Wednesday. Have a lovely Monday. Thank you.
Thank you, everybody. Stay well.